teacher CJ, your science teacher for today. In your previous lessons, you have learned that the Earth's lithosphere is dynamic in nature and consists of different plates. Furthermore, you have also learned that these plates are moving relative to one another. In today's video lesson, we will talk about the evidences that support the said movement of these plates.
Specifically, today we will enumerate the evidences that support plate movement, explain Continental Drift Theory, and explain Seafloor Spreading Theory. Before we start, answer this 5-item quiz. Choose the letter of the best answer and write your answers on your notebook. You can pause the video if you need more time in reading. Let us start. 1. What is the name of the Mesozoic supercontinent that consisted by present continents? A. Eurasia. B. Gondwanaland. C. Laurasia. D. Pangaea. 2. What theory states that the continents were once a supercontinent and drifted? A. Plate tectonics. B. Big Bang theory. C. Continental Drift Theory. D. Seafloor Spreading Theory. 3. What do fossils tell us? A. How long can fossil have existed? B. When and where the plants once existed? C. Determine how long can a fossil decompose? D. None of the given. 4. Which of the following is not an evidence of continental drift? A. Rocks. B. Ancient fossils. C. Magnetic rocks. D. Mountain climatic zones. 5. Which of the following increases with distance from a mid-ocean ridge? A. The depth to the seafloor. B. The age of oceanic lithosphere. C. The thickness of the lithosphere. D. All of the above. To start, let us have these important terms and their corresponding definition. Fossils. Preserved remains or traces of organisms such as plants and animals from the remote past. Lithosphere. The topmost solid part of the Earth that is composed of several plates. Lithospheric plates. Moving, irregularly shaped slabs that fit together to form the surface of the Earth. Subduction. The process in which the crust plunges back into the Earth. Let us first review the previous lessons that have been discussed in the past video lessons. You've learned that the lithospheric plates are moving relative to each other. One of the earliest theory which suggests this is the Continental Drift Theory, which states that all the continents were once a large landmass called Pangaea that broke apart and where the pieces moved slowly to their current locations. This time, let us analyze the evidences that support the Continental Drift Theory. Let us start by looking at this picture. The evolution of Pangaea. The picture shows the shape of landmass from the Permian period up to present day. What can you observe? That is right. It shows how the Pangaea broke apart and evolved into how the continents look today. These Pangaea started to break into two smaller supercontinents called Laurasia and Gondwanaland during the Jurassic period. These smaller supercontinents broke into the continents, and these continents separated and drifted apart since then. Let us take a look at this map of continents at the present day. Focus on the shapes and sizes of the continents. What can you observe? That is right. The edge of one continent surprisingly matches the edge of another. Take a look at South America and Africa. They fit together, as well as India, Antarctica, and Australia match one another. Also, Eurasia and North America complete the whole continental puzzle in the north. So, there you go, our first evidence, the Continental Jigsaw Puzzle. Now, let us move on to the next. Evidence from fossils. Let us first define fossils. Fossils are preserved remains or traces of organisms such as plants and animals from the remote past. Let us take a look and analyze this figure, the distribution of fossils across different continents. As we can see, the continents, namely South America, Africa, Antarctica, India, and Australia are rejoined. We can also see different extinct plants and animals distribution throughout the continents, each with corresponding color. Fossilized leaves of an extinct plant, Glossopteris, were found in 250 million year old rocks. These fossils were located in the continents of Southern Africa, Australia, India, and Antarctica, which are now separated from each other by wide oceans. The large seeds of this plant could not possibly travel a long journey by wind or survive a rough ride through ocean waves. Mesosaurus and Lithosaurus are freshwater reptiles. Fossils of these animals were discovered in different continents, such as in South America and Africa. It is impossible for these reptiles to swim over the vast oceans and move from one continent to another. Fossils were also found in Antarctica. Could it be possible that they existed in this region where temperature was very low? Or could it be possible that long before, Antarctica was not in its current position? Do this. Direction. Answer the following guide questions. Write your answers in your notebook. 1. In which continents are the following fossils present? 2. Do the fossils found in different places prove that the continents was once connected? 3. How do fossils tell us where plants and animals once existed? The third evidence. Evidence from rocks. Fossils are found in the rocks support the Continental Drift Theory. The rocks themselves also provide evidence that continents drifted apart from each other. Rock formations in Africa line up with that in South America as if it was long mountain range. The folded Cape Mountains of South America and Africa line up perfectly as if they were once a long mountain range. The fourth evidence, coal deposits. Coal beds were formed from the compaction and decomposition of swamp plants that lived million years ago. These were discovered in South America, Africa, Indian subcontinent, Southeast Asia, and even in Antarctica. The current location of Antarctica could not sustain substantial amount of life. If there is substantial quantity of coal in it, it only means that Antarctica must have been positioned in a part of the Earth where it once supported large quantities of life. This leads to the idea that Antarctica once experienced a tropical climate. Thus, it might have been closer before to the equator. Apply what you have learned. Direction. Read the given statements. Write yes if the statement supports Continental Drift Theory. No if not. Write your answers in your notebook. Let us start. Number 1. Fossils are preserved remains or traces of organisms such as plants and animals from the remote past. 2. The edge of the continent surprisingly mismatches the edge of another. 3. Rock formations in Africa line up with that in South America as if it was long mountain range. 4. Pangaea started to break into smaller supercontinents. 5. Supercontinents broke into the continents and these continents separated and drifted apart. 6. Glossopteris were found in 400 million year old rocks. 7. Coal beds were formed from the compaction and decomposition of swamp plants that lived million years ago. 8. The Glossopteris fossils were located in the continents of South Africa, Australia, India, and Antarctica, which are now separated from each other by wide oceans. 9. Fossils are found in the rocks. 10. The continent was once a supercontinent. The question as to how the drifting of the continents took place left the Continental Drift Theory blurry. Despite the evidences presented by Wegener, this idea was not accepted by the scientific society until the 1960s. He was not able to explain how this drifting took place, not until the conception of Seafloor Spreading Theory. During the 1950s and 1960s, new techniques and modern gadgets enabled the scientists to discover underwater features deep within the ocean. They found a system of ridges or mountains in the seafloor similar to those found in the continents. These are called mid-ocean ridges. One of these is the famous Mid-Atlantic Ridge, an undersea mountain chain in the Atlantic Ocean which has a gigantic cleft about 32 to 48 kilometers long and 1.6 kilometers deep. The ridge is offset by fracture zones or rift valleys. What is seafloor spreading theory then? It is the answer of scientists Harry Hess and Robert Dietz to continental drift's flaw, an explanation as to how the continents drifted. According to this theory, hot, less dense material from below the Earth's crust rises towards the surface at the mid-ocean ridge. This material flows sideways, carrying the seafloor away from the ridge and creates a crack in the crust. The magma flows out of the crack, cools down, and becomes the new seafloor. Over time, the new oceanic crust pushed the old oceanic crust far from the ridge. The process of seafloor spreading allowed the creation of new bodies of water. Here are the findings that support seafloor spreading theory. 1. Rocks are younger at the mid-ocean ridge. 2. Rocks far from the mid-ocean ridge are older. 3. Sediments are thinner at the ridge. 4. Rocks at the ocean floor are younger than those at the continents. The seafloor spreading theory contradicts a part of the continental drift theory. According to this theory, continents moved through unmoving oceans and that larger, sturdier continents broke through the oceanic crust, whereas the seafloor spreading shows that the ocean is the actual site of tectonic activity. Seafloor spreading was strengthened with the discovery that the magnetic rocks near the ridge follow a pattern aside from the fact that rocks near the ridge are remarkably younger than those farther from the ridge. The Earth's magnetic field is generated in the very hot molten outer core and has already existed since the birth of our planet. The Earth's magnetic field is a dipole, one that has a north pole and a south pole. So, what is magnetic reversal? Magnetic reversal is also called magnetic flip of the Earth. It happens when the North Pole is transformed into the South Pole and the South Pole becomes the North Pole. This is due to the change in the direction of flow in the outer core. Magnetic reversals happened many times in the past. The occurrence of magnetic reversals can be explained through the magnetic patterns in the magnetic rocks, especially those found in the ocean floor. When lava solidifies, iron-bearing minerals crystallize. As these crystallize, the minerals behave like tiny compasses and align with the Earth's magnetic field. So, when magnetic reversal occurs, there is also change in the polarity of the rocks. This allowed scientists to visualize magnetic stripes in the ocean floor similar to the picture shown. Let us wrap this up. Here are the evidences of continental drift theory. 1. The Continental Jigsaw Puzzle. 2. Evidence from fossils. 3. Evidence from rocks. And 4. Coal deposits. Here are the findings that support seafloor spreading theory. 1. Rocks are younger at the mid-ocean ridge. 2. Rocks far from the mid-ocean ridge are older. 3. Sediments are thinner at the ridge. And 4. Rocks at the ocean floor are younger than those at the continents. Now, I want you to reflect on what you have learned through this video lesson by completing these sentence prompts. Write your answer on your notebook. I have learned that I wish to ask my teacher about. To assess what you have learned, answer this 10-item quiz. Read the questions carefully and choose the letter of the correct answer. Write your answers on your activity notebook. You can pause the video if you need more time in reading. Let us start. Congratulations on finishing the lesson. Don't forget to turn in your answers to your teacher for checking. Thank you for watching. Till next time, bye!